So this question says that a stone is released from rest at the end of a building that's 190 meters above the ground. Neglecting air resistance, the speed of the stone just before striking the ground is what? Well, going through the same steps that I tend to do when I solve problems, first thing I do is I draw my picture. So I have my building, and I'm going to release a stone from the ground. Second thing that I'm going to do after reading the question and drawing the picture is I'm going to draw a coordinate system. I'm going to say this is my positive y direction, and this is y equals 0 at the ground. So now I have a coordinate system. That way I know which way my pluses and minuses go. Now let's see if we can read the question again and get some initial conditions, some extra information. So I know that my initial y position is 190 meters. And I know that my initial velocity, because it says it's released from rest, means my initial velocity is 0. And we want to know what is the final velocity at the end when it hits the ground. So going through this, I'm going to look at this, go, well, I know that my final height is equal to 0 because it hits the ground. So I'm going to look and see, I really want to use the equation v final is equal to v initial plus at. My acceleration is equal to minus g in this case. This is g in the downward direction. Minus sign, it's opposite of my coordinate. My coordinate points up as positive. Gravity points down. The acceleration due to gravity points down, so the minus sign comes in there. So I really want to use v final is equal to 0 minus g t. Except for I don't know t. So I'm at a little bit of an impasse. I like the final. If I knew how long it took to hit the ground, I'd have this problem solved. So what I'm going to do is I'm actually going to go over and I'm going to use my y final is equal to y initial plus v naught t plus 1/2 a t squared. Or my final position, y is equal to 0, is equal to the 190, my initial position, plus my initial speed, which was 0, minus 1/2, or plus 1/2, minus g t squared. I have an initial position, final position, initial velocity, gravity is known, I don't know t. So actually I can solve this equation right here for how long it takes, and I'm going to do that. It says that I'm going to move this term to the other side, so it says 1/2 gt squared is equal to y naught, or t squared is equal to y naught, 2y naught over g. Or one last substitution, t is equal to the square root of 2y naught over g. Which if I solve this equation through, I can get a value for it. I don't know what the value is. Actually, I don't care about the time. I care about the speed before it strikes the ground. So I'm going to actually substitute this in. So I'm going to get that the final velocity is equal to minus g. And now what is t? Well, t is the square root of 2y naught over g. A square root and a regular value, these two can be reduced. The final velocity is minus square root of 2y naught times g. Or the square root, negative square root of 2 times 190 meters times 9.8 meters per second squared, which turns out to, I believe, 61 meters per second. I have a negative value, but it's asking for the speed of the stone, not the velocity of the stone. The velocity is in the downward direction. it has a magnitude or a speed of 61 meters per second. It's a little bit of an in-depth problem. There is a shortcut if you use the third kinematic equation, but personally as a physicist, I don't ever remember that one. I remember these two and have to come up with it by doing just an extra step.